Yeah, good day everyone. Now, once we solve this question, once we find the end term of a quadratic sequence, 6, 19, 38, 33, 94. Now, we have linear sequence and we also have quadratic sequence. Now, let me take you back to when we are in maybe primary school. We used to be given this type of questions, maybe 5, 7, 9, 11, and you'll be asked to find this. You'll be asked to find this. Now, this is the first term, this is the second term, this is the third term, this is the fourth term, fifth term, sixth term, like that. Now, the first thing we need to do is to find the difference. The difference, that is T2 minus T1. This is the first term, which is the T1. This is T2, this is T3, this is T4, and so on like that. Now, the formula is T2 minus T1. That is 7 minus 5. This will give me 2. This T3 minus T2 will also give me 2. This will also give me what? 2. So technically, this place will be what? Will be 13. And the last one is going to be what? Is going to be 15. That is, I will be adding 2 to the previous number to get the next number. That is 2 plus 11 will give me 13. Then the difference between here 2 is what? Is 2. So 13 plus 2 will give me 15, and so on like that. Now, where n terms comes in is that, let's assume that we are asked to find the 50th term. The 50th term. Now, I can't be adding 2 to the number till I will get to the 50th term. The 50th term. So, we need to generate a formula that will work for this sequence. So now, since I've gotten the same number, which is constant, 2 is constant, after getting the what? Doing the difference, that is T2 minus T1, T3 minus T2. Now, the difference is constant. Now, the formula is this. Since it is 2, I will write it 2n, because it is linear, so it's going to be what? Raised power 1. If it is quadratic, it's going to be raised power 2. But since it is linear, it's going to be raised power 1. So we are going to have 2n. Then subtract this from this. This first number here, that is 5 minus 2. 5 minus 2. Since we have the same number all through, so 5 minus 2 will give me what? 3. That is plus 3. You add it to this. So this is the general formula, which is the n term we are have to find in this sequence, which is linear. Now, if I should substitute 1 here, since this is the first term, if I substitute 1 here in this n, so I'm going to have 2 times 1, that is 2, plus 3, it will give me 5. If I want to get this now, that will be 2. 2 times 2, that will be 4. 4 plus 3 will give me what? 7. If I substitute 3 here, if I want to get this third term, that will be 3 times 2, that will be 6. 6 plus 3 will give me what? 9. If I want to get this fourth term, like that. Now, if I can use this to get the 50th term, it will be easier for me to get. It will be very, very easy for me to get. Now, if I should substitute 50 here, since I want to get the 50th term, 50 times 2 will give me 100. 100 plus 3 will give me 103. It's as simple as that. So now, this is a different case entirely. For those people writing SAT exam, this question is very, 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 very important. It is very, very important. SAT exams, or you people that are in college, you need this exam, this question. It is very, very important. Now, let's go. I want to find the nth term of a quadratic sequence: 6, 19, 38, 63, 94. Now, we have 6, 19, 38, 63, and 94. Now, let's find the difference. The first difference there, that is T2 minus T1. This will give me 13. Yes. Now, this is T3 minus what? Minus T2. So this will give me 19. This will give me 19. Now, we have T4 minus T3. So this one will give me, it will give me 25. Now, then T5 minus T4. This will give me 31. So I'm going to have this. I'm going to have this. Now, you will notice that in the first difference, it's not constant like this. So it makes this sequence a quadratic. It makes this sequence quadratic because at the first difference there, the difference is not constant. Now, let us do the second difference there. Now, T1, T2 minus T1 will give me 6. T3 minus T2 will give me 6. Then T4 minus T3 will also give me 6. Can you see? Now, at the second difference, we have constants. We have the same number all through. So that makes it what? A quadratic sequence. Now, if you perform your first difference and you notice that it's not constant, that is, the difference is not constant, it's not the same all through, then you perform the second one. You perform the second one. Now, with this second one now, it is constant. That makes it a what? A quadratic sequence. Now, how do we get the nth term for this? After doing this now, you divide the difference by 2. You divide the difference by 2. That is 6 divided by 2. It will give me 3. So we have 3. So this will be 3n squared because it's a quadratic. So we have 3n squared here. Now, the next thing we need to do is to rewrite the sequence. The sequence we have 6, 19, 38, 63, and 94. Now, this 3n squared now, we are writing it here, 3n squared. Now, this my first term here. I will substitute 1 here because it's the first term. I want to get the value here. So 1 squared will give me 1. 1 times 3 will give me 3. So I will have 3 here. Now, 2, second term, if I should substitute it here, that will be 2 times 2, that will be 4. 4 times 3 will give me what? 12. I'm going to have 12 here. Now, the third one, that will be 3. 3 times 3 will give me 9. That is 3 squared. That will be 9. 9 times 3 will give me 27. So this place will be 27. Now, the fourth term there, that will be 4. 4 raised to power 2 will be what? 4 times 4, that will be 16. 16 times 3 will give me what? 48. And the last one, the fifth term, if I should substitute 5 here, that will be 5 times 5 will give me 25. 25 times 3 will give me what? 75. So I'm going to have 75 here. Now, what we need to do here is to subtract. I want to subtract. I want to subtract. Now, 6 minus 3 will give me 3. 19 minus 12 will give me 7. 38 minus 27 will give me 11. Now, 63 minus 48 will give me 13. That will be 5. 5. Then I will have 15. Yes, I will have 15 there. Then 94 minus 75. I'm going to have, I think this place is going to be 19. I think so. Yes, 19. I'm going to have 19 there. I'm going to have 19 there. Now, after doing this now, the next thing you need to do is to find the difference here. Let's find the difference here. Now, that will be T2 minus T1 again. This will give me 4. Now, T3 minus T2 again. That one will give me 4 again. This will give me what again? Will give me 4. That is T4 minus T3 will give me 4 again. Then the last one, this will also give me 4. Now, you notice that at the first difference, we have the same number all through. It's constant all through. So technically, it shows that this sequence here, it's a what? It's a linear sequence. So I'll be writing this guy as 4n. Now, 3 minus 4. That is the first term here minus the difference we have here. So I'm going to have what? Minus 1. So I'm going to have 4n minus 1 for this now. I will now join this and this together. I will add it together. So I'm going to have 3n squared plus 4n minus 1. Now, this will be the n term for this sequence. 3n squared plus 4n minus 1 will be the n term for this quadratic sequence. Now, let us try it. Let us get this first term. If I substitute 1 here, since I'm getting this first term, if I substitute 1 here, I'm going to have 1 times 1, that will be 1 squared. 1 times 3 will give me 3. Then 4 times 1, that will give me what? 4. That is 4 plus 3. That is 7. 7 minus 1 will give me what? 6. Can you see? We are going to have 6 here. Now, if I want to get this second term using this now, if I should substitute 2 here, since I'm getting the second term, I will have 2 times 2. That is 2 squared means 2 times 2. That will be 4. 4 times 3 will give me 12. Now we have 12 here plus 4 times 2 will give me 8. Now 12 plus 8 will give me what? 20. 20 minus 1 will give me what? 19. So now, if I was asked to find the maybe 20th term for this, the 20th term for this now, I will just substitute 20 here. So give me 20 squared times 4 plus 4 times 20 minus 1. Then I will get the 20th term. So if you are given this type of question, maybe in your SAT exam or any exam, this is how you approach it. Thank you.